Hi, welcome back to my channel, Teacher Nonika. Today we continue the next topic, 5.6, interference of wave. So we are still in the same chapter, 5 waves. Okay, let's get started. Okay, we look at the surface of water. If you drop two stones at the same time, what happens to the surface of water? So you can see it will form a pattern like this at the surface of water. Okay, the pattern form actually is due to the wave that interfered or superposed. So this one will cause resultant wave produced due to the wave that interfered or superposed. So this situation or this pattern is formed by the phenomenon of interference of wave. So what is the meaning of interference? Phenomenon in which waves from two coherent sources passing the same point reinforce or cancel each other. Coherent sources means the sources that have same frequency and a constant phase difference. Meaning if the two sources produces wave, the wave all are in the same frequency and a constant phase difference. Okay, look at this one. When the wave interfered, actually it followed the principle of superposition. What is stated by principle of superposition? Resultant displacement at any point where two similar waves cross is equal to sum of the separate displacement of the two waves. So let's say we have two waves that interfered. So it will produce resultant wave. The resultant wave's displacement is equals to the sum of the individual displacement of the two waves. Okay, so the superposition of wave produces two types of interference. So we have constructive interference and destructive interference. So these two types of interference will create a pattern formed on the surface of water. We look at this one. We have 2 points which produces wave. So here you can see the pattern that formed actually is due to interference, that is constructive and destructive interference. Or in this situation, this man is using two spears, the green spear ball. He vibrates or moves the green spear ball perpendicular to the surface of water, thus create two coherent sources, and you can see the pattern formed on the surface of water is like this. Okay, later we explain further how this pattern is produced. Okay, let's look at two types of interference that occur. The first one is constructive interference. Constructive interference occurs when two crests are in superposition or two troughs are in superposition, meaning the two waves which are in phase. You look at this one, P and Q, crest meet crest. So the combined displacement is equals to the sum of displacement of the two waves. So meaning we have the sum, so A plus A equals to 2A. So it produces higher amplitude of resultant wave. That's the reason why we call it constructive interference. Okay, same thing for the two troughs. Two troughs also in phase. So the combined displacement when two troughs meets equals to negative A plus negative A. We put negative because in the opposite direction. Okay, so we have negative 2A. Also larger amplitude in opposite direction. So these two situations, when two crests meet or two troughs meet, we call it constructive interference. So you can sketch the diagram like this to explain this phenomena of constructive interference. The next one is destructive interference. Let's say when the two waves is at constant phase difference, they are not in the same phase like crest and trough. So when crest and trough meet, you can see what happened. This is crest, this is trough. So when the two crest and trough meet, it will produce combined displacement equals to A plus negative A, so equals to 0. So in this case, we get 0 displacement for the resultant wave, or minimum displacement for the resultant wave. Okay, so this one we call it destructive interference. So you can see at the surface of water, at certain point you can see the amplitude of the wave is higher. At certain point you can see there's a calm surface of water. So this situation, if you look at the picture here or this video here, you can see interference occur. It can be caused by the wind that blows, okay, or any other object that cause the interference to occur. So this one will create constructive and destructive, as you can see in this diagram. So area of destructive, you can see the surface of water become calmer. The area of constructive is wavy. You can see the surface of water, okay, the wave is quite higher. So that one will become like constructive interference. Okay, you can see here this one, okay. Okay, higher amplitude is the area of constructive. Where the surface of water become static or calmer, we call it destructive interference. Okay, now we want to sketch interference pattern for water wave. Let's say we have two dippers, S1 and S2. To create pattern of the wave, we use dipper so that it will produce circular wave. For circular wave, we can observe the pattern of the interference clearly. So we use two dippers, S1 and S2. S1 and S2 are connected to same vibrator because we want to produce coherent sources. So now S1 and S2 are coherent sources. Okay, so if you sketch the wave produced by S1 and S2, so we need to make sure that we draw the wavefront at same wavelength. Okay, for example, S1, we represent it with the wavefront, which is the pink color. Okay, and then for the S2 is the blue color. So you can see at a certain point, the wavefront meet. Okay, the broken line in between the two wavefront between two for crest, we call it wavefront for trough. Okay, so the full line we call it for crest and the broken line for trough. Okay, so as we discussed before, in order to produce constructive interference, it's either crest meet crest or trough meet trough. For destructive interference is crest meet trough. So you can see from here, if I look at the first line here, at this point you can see broken line meet broken line. So this is trough meet trough. This one is crest meet crest, trough meet trough, crest meet crest. So the black dot here represent constructive interference, or we call it antinode. Okay, antinode point. If you draw a line to join the antinode point, this line we call it antinodal line. Okay, now look at after that here, the next one, the next line here. Okay, so you can see here, this one is trough meet crest. This is also trough meet crest, trough meet crest, trough meet crest. Okay, so it produces a point where destructive interference occur. So we mark with a cross symbol. So this point we call it node points. So if you join the points by drawing a line, this broken black line, so this one is known as nodal line. Okay, so if you continue to mark all the points, you can see the line antinodal line and nodal line alternately. Okay, so you can see here antinodal line, nodal line, antinodal line, nodal line. Okay, so you can see on the surface of water, actually you can see something like a line. So the line actually represent antinodal line or nodal line. Okay, this constructive interference or destructive interference. Okay, interference pattern, actually we can produce formula. Okay, Let's say we have this formula, x equals d lambda divided by a. X represent what? Is distance between two consecutive nodal line or nodes, or antinodal lines. That one we call it x. Capital D is distance between coherent sources and the line where x is measured. Lambda is the wavelength, meaning distance between two consecutive wavefront for crest or trough. And then small a is separation distance between two coherent sources, meaning distance between S1 and S2. Okay, so this one, we use this formula to describe interference pattern. Okay, let's say we have this pattern, three pattern, pattern 1, pattern 2, pattern 3. Now we want to relate between variables of interference of wave. Just now we discussed this formula, meaning how many variables involved here? 1, 2, 3, 4. 4 variables. You can write lambda equals to ax divided by d, or x equals to d lambda over a. Let's look at the first pattern. So in this pattern, let's say we put d and lambda are constant. This distance d, meaning distance from the source and the line where x is measured, we make it constant, and lambda also constant. Okay, same wavelength. Now the relationship between x and a is inversely proportional. From here, d and lambda are constant, meaning x is inversely proportional to a. So we can say when a increases, x decreases. So you can see the separation distance between the two coherent sources is longer. Thus we get the value of x, or the length of x is shorter. So this one will shows that x is inversely proportional to separation distance between two coherent sources, provided that d and lambda are constant. Okay, next situation. Let's say d and lambda still are constant, but now we make it shorten the distance between two coherent sources. Okay, decrease the value of a. Okay, so what happened to x here? So you can see x become longer. So meaning when a decreases, x increases. Okay, the third pattern, distance between S1 and S2 are constant, and d also constant, but now what we do is we change lambda, use longer wavelength. So you can see the distance between two wavefront for crest increases. Okay, so when lambda increases, x also increases. So you can see here, for same a and d, the value of x increases when lambda increases. So when the question come out, ask you to describe pattern, meaning you just describe what happens to value of x, meaning the distance between two consecutive antinodal line or nodal line. So meaning x also you can measure between two antinodes or two nodes. Ini sama, this between these two lines should be the same distance between two consecutive antinodal line or two consecutive nodal line should be the same. Okay, for the light wave also experience interference pattern. The popular experiment is Young's double slit experiment. So if we look at the diagram here, we use laser pen as the source of the light. Why we use laser pen? Because laser pen can produce monochromatic light. Monochromatic light is a light with one color or one wavelength. Let's say if we use laser pen that produce red color, so the monochromatic light is red. Okay, so in the spectrum of white light, red has the longest wavelength compared to the other colors. Okay, and the shortest wavelength is violet. Okay, so I hope you remember the arrangement of the color, especially the color of rainbow. Okay, that one is spectrum of white light. Okay, So why we use monochromatic light? So that we can see the pattern form clearly. Let's say we want to determine the wavelength of red color or red light. We want to determine the wavelength of yellow light. So we can use Young double slit experiment. Okay, so we can check what happens to the interference pattern if we use double slit with different distances of separation. Okay, let's say we use a double slit with shorter separation, or double slit with longer separation. What happened to the pattern? So you want to describe what happened to the pattern, meaning you go back to the same formula and just describe what happens to X. Okay, now let's look at here. We draw it in 2D. This one is 3D. We draw it in 2D. So this is light source. This is the double slit. Okay, so the double slit receive light from the same light source. So meaning these two slits become coherent sources. Okay, so the light that diffract from the two slits, it will superpose here or interfere here. So in this area, it will create pattern. Constructive interference of light, it will produce bright fringe. Destructive, it will produce dark fringe. So you can see there is a bright and dark fringes alternately form on the screen. So distance between two consecutive bright fringes or two consecutive dark fringes, we call it X. Okay, so we just measure from center to center. Okay, and D here is from the slit and the screen. This is D. Okay, or for the interference of light, lambda is wavelength. A we can define as distance or separation between two coherent sources or two slits. Distance or separation between two adjacent bright or dark fringes. The perpendicular distance from the source and the screen when the value of X is measured. Okay, so this is interference of light wave. Okay, for sound wave, same thing. We can use two loudspeakers that connect to the same audio signal generator, meaning the loudspeakers S1 and S2 are coherent sources. So what we do, in front of the two speakers, we can mark a line PQ. Along the line, we bring a microphone that connected to the CRO. CRO is a device that show the signal or waveform of the sound that will be received. Okay, so what we do, we move the microphone along this line so you can observe the pattern of the waveform produced on the screen of CRO. So you look at here. Okay, this is the audio signal generator. This is S1 and S2, the loudspeaker, coherent. And this is the line PQ. When we move the microphone along this line, at a certain point, the amplitude becomes very small. At a certain point, the amplitude is very high. Okay, so the yellow dot here represent loud sound, and the cross one represent soft sound. So meaning at a certain point, there is a loud sound, then weak sound, loud sound again, weak sound. So there's a series of loud and weak sound alternately. So for this case, also produce interference pattern. Okay, for loud sound actually is constructive interference. For weak sound or soft sound is destructive interference. So meaning for sound wave also we can apply the same formula. Lambda equals to AX divided by D. So lambda is the wavelength of sound. A is the separation distance between the two loudspeakers. X is distance between two consecutive loud sound or two consecutive weak sound. And then D is the distance between loudspeaker and line PQ. Okay, so you can define from here for sound wave. You can read through here the definition for all the term for all the symbol in this formula. Okay, so that one we have discussed for light, sound. Okay, So now we want to discuss about problem solving. If there is a formula, there's always calculation problem. Look at example 1. This is Young double slit experiment. So the slit separation distance between the two slit A is 0.4 millimeter. Okay, capital D, distance from the slit to the screen 3 meter. So distance between two consecutive bright fringes, x equals to 4.5 millimeter. So all given the values. So now we want to apply the formula lambda equals to ax divided by d. But remember, when you substitute the value, you better check all the unit must be changed to the same unit first. You can use the SI unit straight away, or you can choose one unit, like say millimeter, and then you substitute. So at the end only you change to meter. Or you want to change all to meter, then substitute, meaning the final answer is in meter. So this one is the experiment to determine wavelength of the light used. Here no mention the color of light. Say let's say one color of light. So from here we can calculate and get the value of the wavelength of the light used in this experiment. So that's why, as I said before, Young double slit experiment is one experiment can be used to determine wavelength of light. Okay, any color that you want to determine, let's say blue color, yellow color, green color. So you can let the green color pass through the double slit and observe the pattern. If green color meaning green dark, so meaning you just observe the green color. Okay, for the light source, if you use white light as a light source, you can put color filter. Let's say you want to produce monochromatic light, red color, so you put red filter, because a red filter just allow red color to pass through. If you want yellow color, you put yellow filter. Okay, we cannot use white light straight away, because white light will produce a spectrum of colors here. So it's very hard to measure the value of X. That's why we use monochromatic light. Okay, so formative practice 5.6. So you can try first before you check the answer. So for this question, so Young double slit. A, state the phenomenon that occurs when light passes through the single slit. This is a single slit, this is double slit. So when pass through the single slit first, this one is like a gap. Okay, so what happened? Diffraction of light. Okay, and then the light that diffract pass through the two slit, and then interference of light occur. Okay, so now we want to describe formation of bright fringes and dark fringes. Bright fringes occur due to constructive interference. Dark fringes occur due to destructive interference. And the calculation problem, given A, D and X, calculate wavelength lambda of green light. Okay, so you have lambda equals to AX divided by D. So now I use all in millimeter. So in the end I get the answer for the wavelength is 5.52 times 10 to the power negative 4 millimeter. Or you convert to meter, is 5.52 times 10 to the power negative 7 meter. Okay, that one is the wavelength of green light. Okay, application of interference of wave in daily life. So you can see this is a sheep. You can see there's a part here, a bulbous bow. Bulbous bow generates water wave, which interfere destructively with the water wave around the hull. Okay, this causes the wave around the ship to become calmer and thus reduces water drag. Okay, so you can search more on this. So you can search for video or search for image on this one. Next one is about coating the surface of anti-reflection lens causes reflected light to interfere destructively. This helps to improve vision. Okay. And this one, the last one, is microphone and transmitter system in headphones used in aeroplanes produces sound wave which interfere destructively with the surrounding noise. So no noise inside the cabin here. Okay, because they use microphone and transmitter system that can produce destructive interference. Okay, that's all for this topic. So I hope you can understand about this. You must do more revision on this and find new information, especially about application on interference of wave. Okay, that's all. Bye.